Okay, the easiest way to do this is just to be really comfortable with all of the terms in these choices and to know how these different statistical terms interact. So in this story, we are taking of this list of horses, we're taking the one with the lowest reported weight, and it actually weighs 10 pounds less. That's the key idea. So what would change? Well, the first thing that we should know is that the range is going to change, right? We're looking for what remains unchanged. The range is equal to the maximum value minus the minimum value. So if we changed the minimum value, the one with the lowest weight, we're going to change the range, just by definition. That's gone. Then it gets a little trickier. The mean, remember, is the average. And how do we find the average? We sum up all the numbers and we divide it by the number of numbers that there are. Well, we know that that number isn't going to change. 15 horses isn't going to change. But the sum of the numbers is going to change because we're about to subtract 10 from whatever we had before, right? It's 10 lower than it actually is. So the mean isn't going to change a lot because in terms of horses, I don't think 10 pounds is a lot of weight. But it is going to change because the mean, the average, takes into account every single value. And every single value in some way gets plugged into that formula. So if we change one, we're going to change the result. And for that reason, the standard deviation is also going to be wrong because the standard deviation is kind of based upon the average. You don't ever need to calculate it for the SAT, but it is something that's based upon the average and the spread of the data. And so if we kind of like put all this data out, what would happen is we'd have, let's just say all the horses weigh 20 pounds. I know that doesn't make any sense, but let's say they're 20 pounds. And I'm not even going to get to 15. I'm just going to do 3 on each side. There you go. Let's just shorten it. So if we spread that data out differently, right? If one of them suddenly was 10, that data is spread out differently, and that is what the standard deviation is, right? It's when everything kind of bunches up like it does in the top one here. If everything bunches up, that's a very low deviation because all the numbers are kind of the same. So for my example, I'm assuming all the horses weigh 20 pounds. But as soon as one of those numbers kind of moves away from that center, we have a higher deviation because there's more spread. There's more of a deviation from that center point. So it's hard to think about because it's not a number that we can compute as easily as the mean, but it is related to the mean, and so that would change. The median, on the other hand, wouldn't change, right? Because look, if I had all 20s, how would you find the median? You'd cross off from the ends, right? That's how I learned it, until you get to the middle number, and that's still 20. Now, if I changed one of those numbers, it wouldn't matter, right? Because it's the lowest number, so that's still going to get crossed off right away, and I'm still going to work my way towards the center, and that center is going to be the same. So that's the key, is it's the fact that it's the lowest number changing that means the median will never be affected, because the lowest number is going to be the first thing you get rid of as you're working your way towards the middle, which is what the median is. So look, the best way to do this is to really understand these concepts, but you could also do some sort of kind of like fake arithmetize here, like I did, coming up with some fake horses, and actually do the work. You have a calculator, so you could do it. It'll take longer, but it might be a way to save some points if you've got the time. You got options. And my advice is anytime you need to arithmetize a set of numbers with an average, your best bet is to just make all the numbers the same because then it makes the math easier and there's nothing wrong with that. So just copy what I did here.